Hello everyone, my name is Holly Hogue, and today I'm going to be showing you how to use two different tools, FASTTREE and IQ-TREE, which are phylogeny building tools within the program Galaxy. The first thing you'll want to do is go to the NCBI Genome Data Viewer. As you can see, I've already searched for one of my species of interest, Xylocopa sonorina. So now I can search the assembly for the genes that I want to download. So as a reminder, the genes are Wnt10 as well as OBP12. So I'll start by searching Wnt10, and you can see that we have a result here. So I'll click on it, go to region, and I say select gene. So now that gene has been highlighted here in green. Then I go to download, download FASTA, and hit FASTA all selections. So now I've downloaded a FASTA of just the Wnt10 gene from Xylocopa sonorina. My suggestion would be to then go into your downloads in your computer and change the name to something that will allow you to know the gene that you have just downloaded. So for example, XS Wnt10 would be a good way to name this download. So once you've downloaded all of your genomic data, you can navigate to usegalaxy.org. To upload your data, you're going to hit the upload button. You can say choose local file, and select all of the FASTA files that you want to upload. You'll see that the files populate this area here. You can hit start. So now you'll see that all of the files that you just selected appear in this right-hand column of your screen. It might take a couple minutes for all of them to finish uploading. So once all of your genomic data has been fully uploaded here, it will turn green. So now if we open up one of our files just to view it, we'll see that we have both the sequence here as well as the header here. Now, the first thing we'll want to do is actually edit this header. This is for a few different reasons. One is that this piping symbol, Galaxy doesn't really interpret that very well, and it will mess with our analysis downstream. Another reason is that this header is what is going to end up being the label of our branches. So it's pretty congested with information that we don't really need. So we want to change it just to the genus and species name. How we're going to do that is you can go over to Search Tools and find Rejects, Find and Replace. What you'll do is you'll select both genes from the same species. So the reason I'm doing it this way is because then this will make it so that for the same species, we'll have the same header for each gene. So let's do it for Solenopsis invicta. First, you just have to make sure that you select the multiple data sets button. That will allow you to put multiple files in there. You'll notice when I just tried to put two different files, it was set to single data set, and so it wouldn't let me. So just make sure you change it to multiple data sets. All right, so now I've selected the Solenopsis invicta genes, both Wnt10 and OBP. The next thing you'll want to do is go to Insert Check. In this line, under Find Rejects, you'll want to type in this string of characters that's listed in my tutorial. Essentially, what this does is it's going to tell Galaxy to search for the header and everything after that header, but stopping before the sequence. So what we have so far is that this is going to find just the header of both of these files. Now we'll type what we want the header to be replaced with. So for the replacement, I'm just going to say Solenopsis invicta. So now we'll say Run Tool. So now you'll see that we have two different outputs from that tool. So if we view this first one, we see that the header is now just that genus and species. The problem is that now we don't know which gene this is from. We know that this was the reject find and replace on dataset 1, and if we scroll down, we see that dataset 1 was for Solenopsis invicta Wnt10. So what I'm going to do is I'm going to click Edit, and I'll change the name of this file so that I know specifically what it is. So in this case, I'll call it SI Wnt renamed. Hit save, and then we can see that it has updated over here. I'm going to do the same thing with this one for the OBP gene, and then I'm going to do the rejects find and replace for each of our species. So at this point now, you should have all 6 species from the tutorial, and each species should have 2 genes, 2 FASTA genes uploaded into Galaxy. Those genes are OBP12 and Wnt10. Then what you went in and did was you updated the header for each file using regex find and replace. Then lastly, you may have chosen to go through and rename each of these files. So it should look something like this. For example, BVN for Bombus vancouverensis nearcticus, Wnt10 renamed. So this is the Wnt10 gene for Bombus vancouverensis nearcticus. And so you should have something like this for 2 genes for each of the 6 species. So in other words, you have 12 different FASTA files. What you'll want to do now is combine those 12 FASTA files into one FASTA file. So you're going to use the concatenate tail to head tool. So once you have concatenate datasets, tail to head, you select dataset collection, or apologies, you select multiple datasets, and then anything that you renamed. I like to specifically put the word renamed into each title, so that's easy for me to know which of these FASTA files I have changed the header on. All right, so you should have the 12 files here. Again, that's 2 genes for each of 6 species. So that looks correct. Now, all you have to do is hit Run Tool. So once that tool finishes running, you will get a concatenated data set in this right-hand column. So if you hit the eye icon, you can view it, and you'll see that now at this point, we have all of our sequence data in one file, but they're still separated by gene. What I mean when I say this is that there should be 2 different sequences listed under Andrena cerasifoli. So there was one, and we will scroll until we find the second. Second one is right here. So for our next tool, what we're going to do is we're going to combine both of the Andrena cerasifoli sequences from each gene into one heading. So then both of these genes will be side by side under a singular Andrena cerasifoli heading. How we'll do this is another concatenate tool. So you can see we already have it pulled up here. We're going to concatenate FASTA alignment by species. It's already conveniently selected the data set we want. So we want number 25, the concatenated data sets. All we have to do is hit Run Tool. So here is where you see why it's important that we went through and changed all of our headers. That's because this tool will look for headers that are exactly the same. So that's why we didn't put the gene name into that header, because we want to combine both genes under one species and genus header. So now that that has finished running, we can click on the view icon and we'll see that now there's only one heading for each species. So that was Bombus vancouverensis, this is Colides latitarsis, etc. And you can even see here that it says 6 sequences, which is great. That's what we want. That means that we have 6 sequences, one for each species. Whereas down here, we had 12 sequences before we did this concatenation because it was 2 different gene sequences for each species. So at this point, we have correctly loaded all of our sequence data with correct headings into one FASTA file. What we want to do next is align those files. So we will use ClustalW. We have our most recent concatenated data set listed here, so that's great how it is. We correctly have it filled out that these are DNA nucleotide sequences. For our output, we want it to be FASTA. So you can go under Output Alignment Format and select FASTA. All other settings you can keep as their default, and you will hit Run Tool and just wait for that to run. So now you'll see we have 2 different outputs from ClustalW. We have both a FASTA file and a DND format file. If we look at our FASTA file, it won't show all of it because the data set is too large, but we can see that our sequences have been aligned. So now that they've been aligned, we can move on to our first phylogeny building tool. So first we will look at FASTTREE. So FASTTREE will accept FASTA files. So we will make sure that our FASTA from our ClustalW alignment is selected, which here it already is. You'll have to scroll down and change this to a nucleotide alignment. And now all you have to do is hit Run Tool. When the tool has finished running, you'll see that we only have one output from FASTTREE. And it's an NHX format. That just means that it's a series of characters, letters, and numbers that will essentially communicate to a phylogeny visualizer what this tree looks like. But you can also visualize this tree within Galaxy. So just go to the Visualize tab and hit Phylogenetic Tree. And here it will show your resulting tree. You may also want to visualize your tree outside of Galaxy, for example, if you want to open it up in a more customizable platform. So what you can do is you can copy and paste the contents of your NHX file. Then if you go to interactivetreeoflife.com or itol.embl.de, you can select the Upload tab. Simply paste that NHX file context where it says tree text, and then hit Upload. So now we have this same tree, but there's a number of different settings that we could change about it. For example, if you want your tree to be circular instead of rectangular. And there's a lot of different settings that you can play around with to get the tree that you want. So let's come back to Galaxy and take a look at our other phylogeny building tool. So that is IQ-TREE. We're going to want to select that same data set that we plugged into FASTTREE. So the ClustalW alignment, the FASTA format. In IQ-TREE, you'll see we have an option that we didn't have in FASTTREE. So that's the option to specify an outgroup. So we want to put in the species name that we want to be the outgroup. So in this case, we'll say Solenopsis invicta. That's our ant species. The reason that we want to specifically specify this is because if we don't, and it actually says this right here, that if the taxon name is not specified, it will simply be the first taxon in the alignment. So, in other words, it'll be selected somewhat randomly in the sense that the first taxon in the alignment won't necessarily be what you want to be the outgroup. So, it's important that you specify it here. Now we want to scroll down and make sure that DNA is selected for our sequence data. And then just hit Run Tool. And you can already see that we're going to end up with many more different files than we did from FASTTREE. So we'll get 5 different outputs from IQ-TREE, whereas FASTTREE, we just got 1 output. So you'll notice that these turned red. This output turned red, meaning that we got an error somewhere in our tool. You might be wondering why. The reason is because this specify an outgroup text box is very, very specific. So you have to type the header exactly how it is from your files. So in this case, we want to select the one with the underscore between the genus and species. Previously, we did not select the one with the underscore, so it wasn't able to effectively read the header from our files. You'll notice that I don't want to have this symbol, the greater than symbol, because this symbol points to a header. So if we incorporate that, Galaxy will also not read the file correctly. So we simply want it to be genus underscore species, or however you have it listed inside of your sequence file, minus that greater than symbol. So again, we will select our alignment, the FASTA version. Again, make sure DNA is selected, and we can hit Run Tool, and we'll see if this one works. So you can see now that we've incorporated that very important underscore. Our outputs are green, so we got no error that time. You can see your tree by going to the Report and Final Tree and hitting View. You can scroll all the way down, and you'll see we have this tree here. It's comprised of characters, so in a way, the IQ-tree output looks somewhat less professional than the FASTTREE output. You'll also see here that again we have a Newick format for this tree. So if we want to, we can also copy and paste this into ITOL to get that same customizable platform. So that is all I have for you today. Thank you so much for watching, and I hope that this tutorial was helpful in your phylogeny building journey.